Students, let us solve this Irodov problem number 1.47. A solid body starts rotating about a stationary axis with an angular acceleration beta equal to 80. What is the question? This is a solid body. This is the axis of rotation. This body can rotate about this fixed axis. Initially, at time t equal to 0, it starts rotating, means omega is 0. But its angular acceleration have an equation given as beta equal to 80. Now, in common practices in India, we represent angular acceleration with symbol alpha and this constant as a symbol c. So, I write the equation of angular acceleration as alpha equal to ct. The value of c is 2 into 10 to the power minus 2. How soon after the beginning of rotation will the total acceleration vector of an arbitrary point? So we have to consider an arbitrary point. Let me consider this is the arbitrary point. So initially the point is located here, and after certain time the point go here, forming a circle. So the point move in circle having center at this point. Okay. What is the question? How soon after the beginning of rotation will the total acceleration vector of an arbitrary point of the body form an angle alpha with its velocity vector? Okay. Now, what happened after time t? As this particle move in circle, there is a velocity of this particle in this situation. Now, the velocity is always tangential to the circle. So, let me call this velocity as v. Now, what is happening? This particle is moving in circle. So, at this point, there must be an acceleration towards its center because the motion is circular. So there is an acceleration towards its center and we name it as, we call this acceleration as AC. Now for understanding, let me delete these things because we don't need the complete body. We need only the location of this point. So this is the point about which rotation happen. This is the initial position of particle and particle move in circle. So if I call this distance as r, then this distance is also r. Yes, this distance is also radius. Now at this position there is an acceleration towards the center and we call it as AC. Now, if there is an angular acceleration, there should be a tangential acceleration. So there must be a tangential acceleration parallel to the velocity. So this is the direction of tangential acceleration AT. What is the total acceleration? Total acceleration at this point is the vector sum of these two accelerations. So the vector sum means drawing a parallelogram. So this is the parallelogram. So this is the total acceleration vector. So this is the total acceleration vector which is called A. Now in the question it is given that the total acceleration vector, not AC, not AT, the total acceleration vector of the body form an angle alpha with its velocity vector. So this is the direction of velocity vector. So in question it is given that this angle is alpha and this is a right angle triangle. This is a right angle triangle. Length of this line is 80. Length of this line is AC. So I can write it as tan alpha must be equal to perpendicular divided by base. So AC by AT. Now, we have to calculate the time when this phenomena happen. How to do that? This is the equation of alpha. The tangential acceleration is given as AT equal to alpha into R. So, the tangential equation AT is alpha means CT into R. So, tangential acceleration vary with time t. Now, I can write this tangential acceleration as dv by dt equal to c into r into time t. V is the speed of particle. After integrating, I can write it as v2 minus v1 equal to integration of this. So, CR integration of t is t square by 2. What is the initial velocity? Initial velocity is 0. So, final velocity v equal to CR t square by 2. So, at this moment, v equal to CR t square by 2. Yes, this is the v. Now, at this moment, what is AT? At this moment, AT equal to CRT. Yes, this is AT. At this moment, what is AC? So, there is a formula of AC. At any time, if a speed is V, then the value of AC is V square by R. So, square this V. So, it is C square R square t to the power 4 divided by 2 square 4 into R. So, AC is C square R into t to the power 4 divided by 4. So, the value of AC is C square R t to the power 4 divided by 4. So, these are the value of AC, AT and speed V at time t. Now, use this equation. So, from this equation, I can write tan alpha. So, tan alpha should be equal to AC. AC means C square R into t to the power 4 divided by 4. What is AT? AT is CR into T. So, this 1 C should be cancelled out, this R should be cancelled out, this should be cancelled out t to the power 3. So, it comes out 4 tan alpha divided by C equal to t to the power 3. So, the time t should be equal to 4 tan alpha divided by c to the power 1 by 3. So, this is the time at which the total acceleration vector makes angle alpha with velocity vector. So, this is the answer.